Imagine for a moment standing before a structure so vast, so perfectly aligned with the stars, that it seems to defy not only gravity but time itself. A monument built by human hands thousands of years before the invention of cranes, lasers, or computer-aided design. These are not fantasies, they are the enduring legacies of our ancestors, scattered across the globe like silent stone sentinels. They whisper stories of ingenuity that challenge our modern understanding of what is possible. How did ancient civilizations build structures that modern engineers still can't fully explain? Join me as we travel through time and across continents to uncover the secrets of these architectural marvels. Prepare to be astonished as we here at Omniverse Network reveal not just the mysteries of the past, but practical insights you can use in your own life. The story begins now. Number 5. The Great Pyramid of Giza. It stands on the desert plateau, a man-made mountain of limestone and granite. For over 3,800 years, it was the tallest structure on Earth, a record of longevity that is, in itself, a wonder. Its construction involved quarrying, transporting, and lifting approximately 2.3 million stone blocks, some weighing upwards of 80 tons. How did ancient Egyptians move 2.3 million stone blocks with such precision? The question has spawned countless theories, from the plausible to the fantastical. Before we reveal the secret, think about the last time you tried to move something heavy at home. You push, you pull, you strain, feeling the immense resistance of friction and gravity. One leading theory, supported by ancient depictions, suggests the Egyptians wet the sand in front of their transport sledges. This simple act of adding water reduced the friction dramatically. So, the next time you're moving that heavy piece of furniture, place an old towel or a piece of cardboard underneath it. By reducing the friction, you are using the same principle that may have helped build the pyramids. The precision of the pyramid is perhaps even more mystifying than its scale. The four sides of its base are aligned almost perfectly with the four cardinal directions, with an error of less than 1/10 of a degree. By tracking the rising and setting of a star, the Egyptians could determine true north with incredible accuracy. They turned the entire sky into their surveying tool. The internal chambers showcase a level of craftsmanship that is simply breathtaking, with sophisticated structural engineering that demonstrates a profound understanding of load-bearing and stress distribution. Number 4. The Roman Pantheon. In the heart of Rome stands a building that seems to have made a pact with time itself. From the outside, its traditional portico gives little hint of the spectacle within. But to step through its great bronze doors is to enter another world. One is immediately humbled by the vast, uninterrupted space of the rotunda, crowned by a dome that seems to float effortlessly above. Its concrete dome is still the largest unreinforced dome in the world, a title it has held for nearly 2 millennia. Modern structures are often designed with a lifespan of a century or less. Roman concrete was a mixture of lime, volcanic ash known as pozzolana, and aggregate. This unique formulation was not only incredibly strong, but also remarkably durable. As the dome rises towards its central opening, the composition of the concrete changes, using lighter materials at the top, including crushed pumice that can float on water. Here is a practical tip inspired by the Pantheon for your own DIY projects. Think like a Roman engineer. Don't just use the thickest, heaviest materials you can find. Consider where the stress points are. Could you use a lighter material for the upper shelves? Can you add bracing that creates triangles or arches to distribute weight more effectively? Intelligent design, reducing weight where it's not needed, can create something that is both stronger and more elegant. The oculus, the great unglazed eye open to the sky, is another stroke of engineering brilliance. It removes weight from the dome's apex and transforms downward forces into compressive stress. When rainwater percolates through the concrete, it reacts with the pozzolanic material to form highly stable mineral crystals. These crystals fill in the pores and cracks, effectively healing the concrete. It is a self-healing material, a concept that modern material scientists are now trying to replicate. Number 3. Machu Picchu. Perched nearly 2,500 meters high in the Andes Mountains, this Inca citadel remained hidden from the wider world for centuries, a lost city cloaked in cloud and jungle. It feels like a place that shouldn't exist, a dreamscape built from stone. The true marvel of Machu Picchu lies in its stonework. The buildings are constructed using ashlar masonry, where stones are cut to fit together without mortar. These massive polygonal blocks fit together so tightly you can't slip a knife blade between them. The joints are so precise they seem to flow like water, creating a seamless, organic-looking wall that is both incredibly strong and aesthetically stunning. How did the Incas achieve this without modern tools? They had no iron or steel, no wheels for transport, and no written language to record their complex plans. Before we reveal their technique, think about the last time you tried to assemble flat-pack furniture. You have pre-drilled holes, screws, and detailed instructions, yet it can still be frustrating to get everything to line up perfectly. The Incas used a painstaking process of scribing and pounding. A stonemason would trace the irregular shape and meticulously chip away excess until the fit was perfect. Here's a tip from the Incas. When undertaking a project, don't always force a rigid, symmetrical plan. Look at the unique shapes and constraints of your space and materials. Sometimes, the most stable solution is to adapt, letting one piece inform the shape of the next. This mortarless construction had a crucial advantage in this seismically active region. During an earthquake, the stones are said to dance. They can shift and resettle without the wall failing. The Incas were masters of water management. An extensive system of drainage channels and terraces underlies the entire city, preventing landslides and erosion. The Incas did not impose their will upon the mountain, they worked in harmony with it. It is a lesson in sustainable and resilient design, a reminder that the most enduring structures bend with nature rather than trying to defy it. Number 2. The Parthenon. It is the crown jewel of Athens, a symbol of democracy, philosophy, and the birth of Western civilization. At first glance, it appears to be a monument of perfect straight lines and right angles. But this apparent perfection is in fact a masterfully crafted illusion, an architectural sleight of hand designed to achieve visual harmony. The long horizontal platform, the stylobate, actually curves upwards towards its center. If it were perfectly flat, it would appear to droop. This gentle curve creates the illusion of perfect flatness. The columns lean slightly inwards and bulge in the middle. This prevents them from looking like they're splaying outwards and makes them appear perfectly straight and strong. The corner columns are slightly thicker because they're seen against the bright sky, which would make them appear thinner than columns seen against the darker temple wall. So how can you use these Greek principles in your own home? Think about how you perceive space. If you have a long, narrow hallway, painting the far wall a slightly darker color can make it feel closer, reducing the tunnel effect. Placing a large mirror on one wall of a small room can create the illusion of depth. You are using visual cues to manipulate the perception of space just as the Greeks did on a monumental scale. The Parthenon was also a sculpture gallery, richly decorated with some of the finest art of the classical age. The level of detail and naturalism in these sculptures was unprecedented. The Pentelic marble has oxidized over time, giving the Parthenon its characteristic honey gold hue, especially in the light of sunrise and sunset. The Parthenon represents the belief that through reason, mathematics, and understanding of human perception, it is possible to create something of perfect, transcendent beauty. And number 1, Hagia Sophia. For nearly 1,000 years it was the largest cathedral in the world, an architectural statement of such audacity that when Emperor Justinian first entered the completed building, he exclaimed, "Solomon, I have surpassed thee!" Its massive dome seems to float ethereally upon a ring of windows, making it look as if suspended from heaven by a golden chain. The transition from a circular dome to a square support system was the great architectural problem of the age. The solution was 4 massive arches with spherical triangular structures called pendentives to provide a circular base for the dome. The original dome was even more daring, but collapsed following an earthquake just 20 years after completion. The dome we see today is its replacement, built higher and more stable. The building is a dynamic system of forces constantly in tension, with semi-domes and massive buttresses channeling the immense structural loads. Before we reveal the secret, consider how you protect your own home. You think about immediate threats, but the builders of Hagia Sophia had to contend with the very earth shaking beneath their feet. The secret lies in its mortar. Unlike hard, rigid Roman mortars, the Byzantine mortar was made with crushed brick and was much more flexible. It acts as a shock absorber, allowing the masonry to shift during earthquakes without catastrophic failure. When securing items in your home, think about flexibility. Using flexible fasteners rather than rigid bolts applies the same principle. Allowing for movement prevents breakage. The dome was constructed from custom-made lightweight ceramic tiles from Rhodes laid in flexible mortar. This reduced the overall weight that the structure had to support. The interior was covered in millions of gold mosaic tiles that created a shimmering, dematerialized surface, transporting worshippers from the earthly realm to a heavenly one. Hagia Sophia has lived many lives, originally a Christian basilica, then an imperial mosque, then a secular museum, and recently returned to functioning as a mosque. It is a building saturated with the history of empires and religions. It is a building that feels alive, a delicate balance of immense forces held in equilibrium for 1,500 years. It pushed the known limits of engineering to their breaking point and beyond. It teaches us that sometimes the greatest strength is found not in rigidity, but in the wisdom to bend, to adapt, and to absorb the shocks of a changing world. From the celestial precision of Giza to the floating dome of Hagia Sophia, we have journeyed through millennia of human ingenuity. These are profound statements of intent, ambition, and belief, written in the universal language of stone and space. They challenge our modern assumptions and force us to ask what knowledge we may have lost. The builders possessed a patient, observational, and holistic understanding of materials, forces, and the environment. Which of these ancient wonders surprised you the most? Let us know in the comments. We are eager to hear your thoughts and continue the conversation. If you found this journey fascinating, be sure to subscribe to Omniverse Network for more mind-blowing stories from history and practical tips you can use today. By understanding the genius of the past, we can better build our future. Thank you for joining me.